Okay, on your homework for problem 11, they gave you cosine squared of theta equals 2 plus 2 sine of theta. And so there's something I've got to show you because this worksheet deals with solving equations using fundamental trig identities. Okay, so I've taken the liberty of drawing part of a unit circle here in quadrant 1. And you know that the unit circle has a radius of 1 unit. That's why it's called a unit circle. And if I draw a line here that's perpendicular to the x-axis and put theta here in standard position, I know that this distance here is x, and I know that this distance here vertically is y. So I know from the Pythagorean theorem that x squared plus y squared equals 1. Okay? This side squared plus this side squared equals this side squared, 1 squared. Okay? So I can just say it's x squared plus y squared equals 1. Okay? Now, there's some other things that you should know, okay? That if I look at this right triangle, okay, I know that the sine of theta is equal to opposite over hypotenuse, so I get y over 1, or y. I know the cosine of theta is equal to adjacent over hypotenuse, x over 1, or x. So I could replace x with cosine of theta and square it. I could replace y with sine of theta and square it, and I know that that's equal to 1. Well, we can write that as cosine squared of theta plus sine squared of theta equals 1. Okay, and this is a fundamental identity. It's called the Pythagorean identity. An identity is an equation in math which is always true, where cosine squared plus sine squared is always equal to 1. Okay, so that's going to be very useful in this problem up here. Okay, so going back to this problem, I'm going to do some algebra, and I'm going to subtract 2 and 2 sine theta from both sides. And so I get cosine squared of theta minus 2 sine theta minus 2 equals 0. Now, that looks like a quadratic that I should be able to factor, but the problem is I don't have like terms. It'd be really nice if this right here could be replaced with something involving sines. Well, it can. If I look at my Pythagorean identity here, if I took cosine squared theta equals sine squared theta minus 1, cosine squared theta plus sine squared theta equals 1, I could subtract sine squared theta from each side of my equation and get cosine squared theta equals 1 minus sine squared theta. Okay, so I can replace this cosine squared theta with 1 minus sine squared theta. This part here just took the place of cosine squared theta. Okay, that's why I have them both with this under bracket. Alright, now I'm just going to simplify this a little bit. Negative sine squared theta minus 2 sine theta minus 1 equals 0. And then I'm going to divide everything by negative 1. And now I'm going to factor that, and it factors like so. So I get sine theta equals negative 1, or sine theta equals negative 1, which are the same equation, and that's true where theta equals 3 pi over 2. which is the answer to that problem.